Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to our video channel. StratusGrid is an AWS Premier Consulting partner, and we're also an ISV. We have this product called Stratosphere, which is a FinOps tool that helps you to find cost savings opportunities within your AWS organization across all of your different AWS accounts and services that you're using. And this really helps enterprises and private equity companies to go out and really get the most bang for their buck in their AWS environment. So identifying resources that aren't actively being used or underutilized and just going out and cleaning those types of things up can really save you a lot of spend in your AWS accounts. It's really easy for engineers to just go out, spin up some resources, rack up a huge bill, and never get any value from those cloud resources. But this tool is designed to help you identify those types of underutilized resources and then identify those so that you can go out and take action on them to clean them up or reconfigure them to maybe a lower cost pricing tier or something like that. So if you're interested in seeing a demo of Stratosphere, then hit this little button up in the corner called Let's Talk, and we'd be happy to give you a demo. And the onboarding process only takes about 10 to 15 minutes to spin up a CloudFormation stack, and that'll get you onboarded into the product. We'd love to talk to you and see how this could help you out. So what I wanted to talk about in this particular video is a kind of cost optimization guide for the Amazon DynamoDB service. There's lots of different services within the AWS ecosystem, right? If we click on services up here, we've got all these different service categories up here. We've got compute, containers, database services, and things like that. And one of those services is Amazon DynamoDB. And this is a NoSQL service. Basically, it's a document storage engine rather than a relational data model that you have with a MySQL or PostgreSQL and that kind of thing. And a lot of applications that are serverless will actually take advantage of a serverless solution, a managed service in AWS like DynamoDB in order to store data for that application. And there's a lot of different reasons that an application might use DynamoDB as an alternative to a traditional relational model, right? And that could be because it's a managed service. There's no infrastructure. You don't have to install any server software. You don't have to configure security on it or anything like that. It uses HTTPS or TLS encryption by default for data in transit. It integrates with AWS's key management service for encryption of data at rest on the AWS infrastructure. It's got built-in monitoring with CloudWatch metrics and that kind of thing as well. And so it's a really great solution. If you're looking for a document storage engine, but you don't want to spin up something like Apache Cassandra or CouchDB or MongoDB or other types of database products like that that would kind of compete with DynamoDB, then this is just a really fast way to get started. And one of the great things is that you get the elasticity of pricing in the cloud. So you're only going to pay for the storage and the throughput that you're actually consuming with the DynamoDB service. So that's a couple of great reasons to use DynamoDB to store data. And I've actually got a series of videos that talks about how to develop Rust applications that actually talk to the DynamoDB service to store items and retrieve items or documents out of the DynamoDB service. So feel free to check out the other videos on our channel if you're interested in learning more about how to actually use DynamoDB. But this video is really going to be more of a cost optimization guide. So let's say that you are a brand new DevOps engineer to a company. You are introduced to an AWS organization. They've got maybe 50 different AWS accounts. You're looking at all these different regions where there's DynamoDB tables kind of interspersed through all these different regions and accounts. And it's kind of your job to identify any cost savings opportunities for DynamoDB. And so I wanted to kind of walk you through some of the different attributes of DynamoDB tables that you'll want to inspect in order to determine, is a table being unused? Yes or no? It's very possible that somebody could spin up a table, put some data inside of that table, and then never reference that data again. And so we want to avoid those types of situations, right? So we need to be able to have some way of determining if a table is actively being used by an application or even just an end user who's browsing the table directly inside of the AWS Management Console. We also want to be able to determine if our capacity configuration for our DynamoDB table is configured correctly. So when we go out and create a brand new table in the DynamoDB service here, one of the options that we have is to customize our configuration of our table, and then we can choose the pricing mode. We can either pre-provision a certain amount of capacity units, read capacity units and write capacity units, depending on if you're retrieving items out of the table or writing new items or updating items in the table. And we also have the on-demand mode here where you don't have to specify how many capacity units you have. You simply pay based on how many units you actually consume, which is great for development purposes. It's great for applications that don't really have a high level of traffic. But once you start scaling up your applications, you want to kind of take a look at the provisioned mode because it does actually come in at a lower price if you're consuming a lot of capacity units. So that's another thing that we want to look at is what are our capacity units set at for our different tables, and it also supports auto scaling. So there's actually two different services kind of at play here. We've got the DynamoDB service itself, where we have the read capacity units and write capacity units, but then there's a separate service with different APIs called the Application Auto Scaling AAS service. And the DynamoDB service and the Application Auto Scaling service kind of work together in tandem so that when a certain threshold is hit, the Application Auto Scaling service can actually call out to your DynamoDB table and reconfigure that table dynamically so that you can either increase or decrease the capacity units that are allocated to your table on the fly so that your application can scale without manual intervention. And that's great because it allows you to scale up when demand on your application is high, and it allows you to scale down when demand for your application is low. And again, you don't have to manually touch those controls because the application auto scaling service handles all of that for you. But it's important to answer the question, do my DynamoDB tables have the provisioned mode enabled? And if they do, is auto scaling enabled for those tables? And if it's not, is this workload going to require that I enable application auto scaling? Or can I just leave it off because that particular workload that's accessing that particular table is extremely consistent? Maybe it's just gathering metrics and putting those metrics in, so it's a very consistent type of workload across any given time of the day or week for that matter. And so in that case, you could probably safely leave auto scaling off. But it does require a little bit of analysis, a little bit of introspection about the applications and workloads that are running within your organization so that you can figure out what the best configuration is for your DynamoDB tables. Something else that we have here is called reserved capacity. What this allows us to do, it's kind of similar to like AWS savings plans or reserved instances where you can pre-purchase a certain amount of capacity for compute services like EC2 or AWS Fargate and things of that nature. But what reserved capacity is it's basically that same concept where you can pre-purchase a certain amount of capacity in terms of read capacity units and write capacity units, only we're doing it for the DynamoDB service specifically, right? And so we can specify the region, first of all. So of course, that's going to depend on what region we have selected in our AWS Management Console here. And once we select that region where we want to purchase the units from, we can choose if we want to pre-purchase read units or if we want to pre-purchase write units. And when you choose one of those options, it'll give you the option for either a 1-year term or a 3-year term. So those are the two different options you have. Again, very similar to AWS savings plans and reserved instances, where you can choose if you want a shorter term reservation or a longer term reservation, depending on how long you anticipate that particular workload running for. Now, when it comes to the actual capacity units here, everything in DynamoDB really depends, it kind of hinges on this notion of a capacity unit. And we'll talk about what a capacity unit is. But when you are pre-purchasing this reserved capacity feature here, you can reserve in increments of 100, right? So if I try to do 101, it's going to say, no, it has to be a multiple of 100. Or if I say 153, then it's going to, once again say it needs to be an exact divisible number by 100 with no remainder. So we could say 200, we could say, 1500, we could go all the way up to 100,000 if we really wanted to. And it says if you need more than 100,000 capacity units, you can actually make multiple purchases. But in order to actually make a purchase for reserved capacity, you really need to understand the access patterns for your tables before you can really make a reservation. You don't want to reserve a bunch of capacity only to have that go to waste because you're not actually consuming that capacity across the 1 or 3 year term of that reserved capacity purchase that you make. Also, do be aware that reserved capacity is tied to a specific region, so make sure that you select the appropriate region where your table exists and that it's going to exist there for the foreseeable future. And you can actually share reserved capacity across multiple AWS accounts within your organization as well. So if you want to centralize all of your purchases into a payer AWS account and then have those apply to the AWS accounts where the actual workload is running, where the actual table has been provisioned into, you can certainly do that. And there's great documentation for the DynamoDB service that kind of talks about how to make those types of purchases. So that's another vehicle that we have to kind of cost optimize here. And we're going to go through these things in a little bit more depth here as well. So right now, I just want to kind of give an overview of some of these things. Now, something else that you'll want to pay attention to are your indexes. And I have a couple of other videos that talk about local secondary indexes and global secondary indexes with the Rust programming language. You could apply some of those concepts that are just generic to DynamoDB, not Rust specific. And you can really learn a lot from those, but they do actually show you how to write Rust code and actually use these indexes as well. So if you're interested in that, feel free to check out those videos. But what an index is it's just a different access pattern for the items that are inside of your DynamoDB tables. So we have two different types. We have the global secondary index, and the global secondary indexes are actually a little bit unique because they actually have their separate provisioned capacity from the base table. So if you have a table and you have a global secondary index, the table has its own provisioned capacity for read and write capacity units, and then the global secondary index has its own separate read and write capacity unit configuration from the table itself. So each GSI has its own capacity configuration. And you can see that if the table is configured for on demand, then the GSI also has to be on demand. But if I change the table to be using the provisioned throughput model, then the GSIs would also use that provisioned throughput model, and they'd have their own numbers for RCUs and number for write capacity units, WCUs, that you want to provision for those global secondary indexes. Now, with local secondary indexes, they don't have that same attribute as global secondary indexes. When you query data, when you read data from a local secondary index, you're actually just consuming read capacity units from the base table's configuration. They don't have a separate read capacity configuration from the base table. So just be aware of that. It's a little bit different. But one of the things that you can do to cost optimize is to optimize the RCUs and WCUs if you're using the provisioned throughput mode for your base table. And so you can actually go determine how many capacity units are actually being consumed by the base table as well as the GSIs that have their own separate capacity units, and then determine if they are sized appropriately. With the Amazon EC2 service, you might be familiar with right sizing, where if you over provision an EC2 instance and you have 16 virtual CPUs, but you're really only using about 25% of that capacity, well, if you want to right size an EC2 instance, you might shrink that from 16 virtual CPUs down to maybe 8, or maybe even down to 4, if you think that that's going to be adequate for the workload. And so it's kind of the same concept here, where we just want to right size our indexes and base table configuration to make sure that they have the correct number of write and read capacity units allocated to them based upon our workload's access patterns to that table. So that's something else we'll want to pay attention to. Plus, we can actually delete indexes as well. So If we want to, we can come in here to global secondary indexes and we can just say delete, and we can just kill off that index so that we're not billed for the additional storage and the additional capacity units that are being provisioned for that particular index, right? Now, unfortunately, with local secondary indexes, if you watch the video that I did on LSIs specifically with Rust, then you'll know that LSIs can only be defined, either added or removed at the table creation time. So if you've created a table with an LSI, then you're stuck with that LSI until you delete that table and recreate it from scratch, and then, find some way to restore your data back into that table, right? So that's something you want to be cognizant of as you're dealing with this as well. Something else we want to pay attention to here is backups. So point in time recovery is a really cool feature that allows you to restore up to 35 days of history down to, I think, like the second level. So we can kind of find a point in time where we want to restore our table to. Maybe we had some kind of bizarre application behavior at 2 p.m. yesterday. And so I want to say, I want to restore at 1:59 p.m. and bring my table back to the configuration right before the application went haywire and started corrupting the data inside of my DynamoDB table. But that's not really what we're talking about here. What we're talking about is the backups feature down here that allows us to take essentially snapshots of our DynamoDB table so that we can restore back to those. Now, the difference here is that backups actually are longer lived, right? So point in time recovery is just kind of a backup that's managed on an ongoing kind of sliding window by the DynamoDB service, but you can actually, as an end user, come in here to the DynamoDB service and say, hey, I want to take this backup here. I want to restore it to a new table. I can also create an on-demand backup as well. So this is one way that you can create backups, but what can happen is if you take a bunch of on-demand backups through the DynamoDB console or through the APIs for DynamoDB, then you can end up with a huge number of backups that are simply costing you storage money, right? So you're going to rack up your AWS bill, especially if you have really large tables. In fact, right down here, you can see I have the size attribute here. Of course, this is just a demo table, so it's a very, very, very small table. So I don't really have to worry about my costs in this particular case. But if you had a really large production grade DynamoDB table that's been gathering data for years and years from, millions of end users of your application, then it's very possible that you could have a DynamoDB table that's maybe 200 gigs in size, some massive number. And if I start taking, let's say, daily backups, that's 200 gigs of storage that I'm paying for every single day, cumulative for the backups in my DynamoDB table. So I want to make sure that as a FinOps engineer, that I am conscious of the backups that have been taken for a particular table. I'm determining if those backups are necessary according to my organization's backup policies, retention policies, and make sure that I'm cleaning out any backups that are unnecessary for whatever reason according to my company's policy. And you can automate this through the API. I certainly can come in here to the console and just select a backup here and say, hey, I want to delete this specific backup. But if you're dealing with, tens or hundreds of backups across different tables, across different regions, across different AWS accounts, then that's probably a situation where you're going to want to automate the process using something like the PowerShell tools for AWS or the AWS CLI or the Rust SDK or whatever SDK for AWS that you want to use. Doesn't really matter, but you'll probably want to automate that through the DynamoDB API. Now, DynamoDB also allows you to schedule backups. So in this little button down here where it says create backup, you might see this kind of external link thing here that says schedule backups. So when you click that, this is actually going to take us to a different service called AWS Backup. Now, AWS Backup is its own service with its own set of concepts that you kind of want to understand. And AWS Backup actually integrates with DynamoDB as well as other services in order to create backups based on a plan, right? So you can set up a plan, you can set up your backup parameters, you can set up a retention policy. I think that's part of the, can't remember which part that's a section of. It might actually be part of this backup plan right here. So let's just say build new plan, give it a name, and then we can specify how frequently we want backups. We could say like hourly, do a custom cron expression here if we wanted to. And then we can specify the life cycle here. So we could say, I want to keep, let's say, 250 days of backups, and I can even move backups from warm storage to cold storage. So I can spend less on storage, but more for data retrieval costs in the event that I do actually need to restore a data backup. And then I can say, all right, well, how many days does it stay in warm storage? So I'm going to keep it warm for, let's say, maybe 2 weeks. And then we'll say, I want to keep it for maybe another 250 days beyond that. And so that's going to give me about a 8-month window here, 2 weeks in warm storage, 250 days in almost 8 months in cold storage. And so this allows me to kind of create this backup plan that sets up a bunch of parameters and can automatically delete old backups. So if you are using the DynamoDB APIs to create manual snapshots or on-demand snapshots, then you might want to consider actually moving over to the AWS Backup Service that allows you to automate that whole cleanup process. And that way you can kind of help prevent the additional spend that comes from just ancient backups sitting out there costing you storage money in your AWS bill. So that's something else you want to pay attention to. Now, I want to switch gears a little bit and actually talk about the capacity units again, because understanding what a capacity unit is really essential to understand how the whole pricing model works. Should I use on demand or should I use the provisioned throughput model, right? Or, how many capacity units should I be allocating based on my workload, based on the item size, based on how often items are being retrieved? Am I retrieving 100 items every second? Am I retrieving one item every 10 minutes, maybe? A very low utilization type of application. So generally, if you want to understand what a capacity unit is, you can check out the DynamoDB documentation. And I'm actually just going to do a Google search for DynamoDB capacity units here. And you'll see it takes us over to this read-write capacity mode. And then if we head down to the provisioned mode section here and scroll down just a little bit further here, we're actually going to see somewhere here what a capacity unit is. Actually, it's right here. This is under the provisioned mode heading, read capacity units and write capacity units. So a read capacity unit is defined as a strongly consistent read per second, or if you use eventually consistent reads, then you can do 2 reads per second for an item that's up to 4 kilobytes in size. So I'm going to retrieve a single item from a DynamoDB table that is up to 4 kilobytes in size. And if I use strongly consistent reads, then that will only cost me 1 capacity unit. Now, if I do a strongly consistent read for a specific item, but that item is larger than 4 kilobytes, like let's say it's 16 kilobytes, then that's actually going to cost me 4 read capacity units because I can only get 4 kilobytes per capacity unit. So I have to multiply 4 times 4 to get up to 16 kilobytes for that one item. Or if I use eventually consistent reads, then that doubles my capacity, but I'm still limited to 4 kilobytes. So I'd still have to do 4 read capacity units in order to get a 16 kilobyte item from the table, right? But if I wanted to retrieve 2 2 kilobyte items, then that meets the 4 kilobyte maximum size, and I could do 2 eventually consistent reads for 2 different items within that capacity unit, right? So it's a little bit of a confusing concept, but once you kind of think about it a little bit, do some calculations over a period of time, it starts to make a little bit more sense. Write capacity units are similar, but a little bit different. So the writes are 1 write per second. So let's say I put a new item into a table, right? Let's say I just write a new item into the table every second because I'm gathering some metric data and I'm just going to write a new item into the table every single second. So that gives me the ability for 1 write capacity unit to write 1 item up to a kilobyte in size every single second. So let's say that I have some metrics gathering application, and every second it goes out, grabs a metric value from some service, and then it just writes it into the DynamoDB table once every second. So that would give me the necessity to have 1 write capacity unit for my table to accommodate that workload. Now, if you're scaling that up and you're actually gathering metrics for lots of different services once every second, then of course those write capacity units are going to increase. Or if you're writing a very large item, let's say you're writing a 100 kilobyte item into a DynamoDB table. If I recall correctly, the maximum item size for one item is, I think, 400 kilobytes. Don't quote me on that. But if you had a 100 kilobyte item that you're writing every second, then you're going to need 100 write capacity units to accommodate writing a 100 kilobyte object once every second, right? So again, the calculations can be a little bit confusing, but just think through it a little bit and eventually it'll make sense. So now that we understand what a read capacity unit is, one strongly consistent read per second up to 4 kilobytes in size, and a write capacity unit, one write per second up to 1 kilobyte in size. Now we can take a look at the pricing page and actually do some calculations to figure out how many, or basically what it's going to cost me if I assume certain input parameters. So let's check out the pricing page. Something else you could do too is actually to go out to ChatGPT at chat.openai.com, or there's other tools out there like Anthropic is another company that has a LLM that's kind of similar to ChatGPT called Claude. They just released Claude 3 recently, which is actually now available through Amazon Bedrock, which is an LLM kind of managed service. So there's other ways to get answers to your questions here as well. So one of the things I could do here is say, what is the cost for 100 capacity, let's say write capacity units per month in DynamoDB? And so that's going to kind of calculate out the costs across an entire month, right? But I'm not necessarily going to trust its math. I'm just going to do the math myself. So let's do a search for DynamoDB pricing. We'll head out to the marketing page for the DynamoDB service. And the structure of the pricing page for DynamoDB is a little bit different from other services because it has a couple of different modes, right? We have the on-demand capacity mode, and we also have the provisioned capacity mode where we can specify how many capacity units should be available to a particular table. So if we take a look at, for starters, at the on-demand capacity mode, this is basically a way for you to create a table. So you're always going to be paying for the storage. As long as you have a table and items in that table, you're going to be paying for the storage for those items, right? But with the on-demand capacity mode, if you are never doing any reads or writes to that table, you just create the table, put some items in it, and you just leave it there. You never touch it, then you don't really have to worry about spending any money on the read or write capacity units because you're only paying on demand for the capacity units that you're actually consuming. So if I do a read operation, then I'm going to pay for that. If I do a write operation, I'll pay for that. But if the table's just sitting out there, I'm only going to be paying for the storage in the on-demand pricing mode. So if we take a look at the actual costs for this mode right here, we'll scroll down a little bit, and it's a little bit complex here. We have to calculate our data storage. And so the cost for the standard table class, there's two different table classes. I don't recall if we discussed those. There's standard and standard infrequent access, or IA. And so if we have the standard table class, it's kind of like hot storage, so to speak, then we would be paying 25 cents per gigabyte per month for a table. So if I create a table and I put 1 gig of data in terms of items, just aggregate a gigabyte of data into that table, then it's going to cost me 25 cents for the storage each month. Now, if I change the storage class of the table to standard infrequent access, standard IA, that's kind of like cold storage, where you pay less for the storage, but you pay more if you actually want to read or write data into that table. So that brings the cost down significantly for the storage. So we're only paying 10 cents per gigabyte per month now. So that's less than 50% of the cost for the standard table class. So that's one factor that you have when you're dealing with this. But remember that we also have to pay for the read and write requests, the capacity units. So right down here, if we have on demand and we're using the standard table class, then we spend $1.25 per million write request units. And remember, writes are 1 write per second, and the items can be up to a maximum of 1 kilobyte in size. Reads are different because they can be up to 4 kilobytes in size, but writes are up to 1 kilobyte in size. And then for read request units, we have 25 cents per million read request units, right? And so this is basically telling us what we're going to pay based on actual consumption. So if I create a table, an empty table, brand new empty table, standard storage class, and I just write 100 tiny little items. Let's say they're like 10 bytes in size, just very minimal size. That's under that 1 kilobyte threshold, right? So I just write 100 items that'll use 100 capacity units. And so I can extrapolate. I can say, okay, well, if it costs me $1.25 per million, then how much would it cost me for 100? Well, I basically just divide that up down into 100 rather than a million, and that'll tell me exactly what my cost is going to be. So on-demand pricing mode, again, is nice because we're not paying for capacity that we may not actually be consuming, but it is going to be more expensive if you have consistent throughput, both reading and writing to a particular table. And so that's where the provisioned capacity mode comes into play. So if we take a look at the provisioned capacity mode, take a look at data storage, you can see that the data storage doesn't change, right? We still pay the same rates for the actual data that's being stored inside of the DynamoDB table. But what's different about the provisioned capacity mode is the read and write requests. So in this particular case, rather than just paying based on what we're actually consuming, we're kind of reserving a certain amount of capacity on an ongoing basis. So when I put my table into the provisioned capacity mode, I'm basically saying, I want this amount of capacity to be available at any given moment for my table. And so what we're doing here is saying that a write capacity unit is going to cost this kind of fraction of a penny down here, right? And so what this is going to do is it's going to allocate one capacity unit every single second. And so if I have an application that's writing once every second, a very tiny item under 1 kilobyte of size, then that's going to be adequate, is one capacity unit. Now, if I'm writing a 100 kilobyte item once every single second, then that one capacity unit is not enough. I now need 100 write capacity units, right? So basically, I just move the decimal over one. So rather than being 0.00065, it's 0.0065. Or if I multiply it by 1,000, right, that's another zero off. So basically, what we're doing, or actually, I think it's, I think I said 100 would be 2 zeros. So we'd actually move it over 2 zeros. So 0.065. So in that particular case, it would cost, 6.5 cents for 100 per hour. So that's a little bit confusing because we're actually pricing it per hour. So we have to figure out kind of on a per second basis what that's actually going to allow us to do. But again, if our application is writing, let's say, a 100 kilobyte item once every second, then we're going to need to provision 100 capacity units. We can calculate out what that's going to cost us per hour. We can multiply hours into, let's say, just standard 720 hours per month, and that'll help us to determine what the actual table cost is going to be as far as write capacity and read capacity units go for that table. Now, if you multiply this out and you actually look at what would a million capacity units cost using the provisioned throughput mode versus the on-demand mode, this price is actually going to come out lower because you are kind of committing to that provisioned throughput rather than just allowing the DynamoDB service to charge you based on what you're actually consuming. So again, if you have a very consistent workload that's actively consuming read or write capacity units, it's to your advantage to try to configure your read and write capacity units according to the needs of your application. Now, again, if you have the provisioned throughput type enabled for your table, you can enable the application auto-scaling feature, and that will help you to dynamically scale the table if your demand does actually increase. So maybe your normal baseline is 100 write capacity units. So 100 write capacity units every single second, right? And if that's the case, but sometimes it bursts up to 1,000, right? Sometimes I need to 10x my traffic. Then in that case, we can enable application auto scaling. We can set some auto scaling parameters on it. So if we come back here to create a table and we say customize settings down here and go to provisioned and say for read capacity, I want auto scaling. I'll just say go to maximum of 5, but we're talking about writes here. So I'm going to say my minimum should be 100 because I know my baseline is always going to be 100, but I might need to burst up to 1,000 sometimes, right? And so then I can set a target utilization here and say I want to be always at least utilizing 70%. And this is going to affect the ability for it to scale accurately. So the more accurate that you want it to be, the harder it's going to be for it to kind of make sure that there's full utilization. But if you give it a little bit more leniency, like say I only want to use, at least 60 to 70%, that gives it a little bit more freedom in terms of the scaling operations that are actually occurring in the background. And you can read about that more in the documentation for DynamoDB. But if you do have a significant level of delta between what your peak performance is for your table versus the kind of baseline performance for the table, it is in your advantage to enable application auto scaling for that table because that'll take care of the scaling for you. Or if you'd like to, you could actually write your own auto scaler using something like Lambda functions and use schedule-based scaling events using Event Bridge or something like that. So we could, go out to Event Bridge, create like a time-based rule or something like that. Say like at 8 a.m., I'm going to kick off this Lambda function that scales my table up to 1,000 capacity units. And then at 5 p.m., I'm going to create another schedule that downscales it back to 100, right, capacity units, right? And so you could kind of play around with different event-driven, whether it's time-based or some external applications kind of driving events to trigger those scaling things. It's really up to you as far as how fancy you want to get with it. But generally speaking, the provisioned model is going to make sense for most applications that have very consistent work to do. Now, I want to go back really quick and actually talk about the table class right here. So we do have two different table classes. We have kind of the hot storage, the standard storage, and then we have standard infrequent access. And the standard infrequent access, again, has a significantly lower 10 cents per gigabyte per month rather than 25 cents per gigabyte per month for the storage, right? The difference, though, is that your costs for data retrieval are going to go up a little bit. So if we take a look at, let's say, on-demand capacity mode, and then we take a look at the read and write requests here, you're actually going to see that if you are using the standard table class, the kind of hot storage, so to speak, then your cost to write data or to read data is a little bit lower than the cost to write or retrieve data using standard infrequent access. And so that's how they're kind of offsetting things, right? So you're going to pay less for the storage, but if you do need to actually read and write data, it is going to end up costing you a little bit more, right? So if you do have a particular workload that is just kind of having table storage sitting out there that needs to be accessible, but not very frequently, then you probably want to switch your tables over to using standard infrequent access so that you're not paying such a high price for the underlying storage for the data in that particular table. Because DynamoDB is a little bit pricey for storage just because it is a managed service, right? You're not having to manage any of the infrastructure. It's significantly more expensive than something like S3, for example, where you might pay something like 9 cents per gigabyte to store data. But again, there is a lot of benefit because you're actually accessing a database service under the hood, right? So just keep that in mind as you are calculating things out here. Now, one of the other things I wanted to talk about is determining the usage of a table. So if you're not enabling auto scaling and you're just trying to figure out, is this table even being utilized at all, right? If I come into an environment and there's a bunch of tables sitting out there, and I don't know if these tables are being used, if they're not being used, how much are they being used, who's accessing them. These are some situations, these are some questions that I'm asking where I need to get some data. I can't answer these questions unless I have some data to tell me if somebody's using the table or not. So there's a couple of different things we can do, two different main things that we can do to find out answers to these questions. Over in the AWS Management Console, I can head over to the Amazon CloudWatch service. And CloudWatch is really handy because it gives me access to a bunch of different things, in particular, metrics. Now, DynamoDB actually emits metrics directly into CloudWatch. You don't have to do anything. It just does that. When you create a table and you start accessing items in that table, it's going to emit metrics into CloudWatch inside of your AWS account. Of course, you have to make sure you're in the same region as the table. So when we're over in CloudWatch and we go to the All Metrics service here, we can actually just explore all the different metrics that are inside of our AWS account in this particular region. And so if we click on the DynamoDB namespace right here, it drills down into a few different categories. First of all, you'll see that we have these separate metrics for global secondary indexes. And we talked a little bit about that earlier in this video. We talked about how there's separate provisioned capacity for a global secondary index, whereas local secondary indexes just use the capacity from the base table. So if we do have global secondary indexes, then we can actually look at the consumed read and write capacity units. So we can actually find out just by looking at these metrics if anybody is using these tables or not. So let's say that I have this table right here called Trevor Products Provisioned. Well, I have consumed capacity units and I have provisioned capacity units. So let's say that I have 100 capacity units, write capacity units provisioned for a table or a global secondary index in this particular case, but only maybe 10 capacity units are actually being consumed. So that delta of 90, 100 minus the 10 that are actually being consumed, is the potential cost savings for this particular GSI. And the same thing applies to tables as well, but in this case, we're looking at GSIs. So I would want to take a look at, okay, what is the actual consumed write capacity units? And in this case, I don't have a workload that's accessing it, so it's going to be 0. But in a production table, you might have, maybe 10, maybe 100, something like that. And so this is going to tell me if the GSI is even being accessed at all as far as writes go. I can also do the same thing for consumed read. Is there any consumed read capacity? And once again, you can see that there is no active read capacity here. And these metrics, I believe, if we go to period over here, I think we might be able to get them down to the per minute level. Yeah, so we actually get per minute metric data points. And I could drill down to, let's say, just the last hour here. So I can see at, 7:20, 7:21, 7:22, et cetera, I can see every single minute if there's any activity happening on the read capacity for that GSI. And if I go back maybe a week, and I can see that there's an average of 0 consumed read capacity, then I can probably say nobody's reading from this GSI. And then again, same thing for the write capacity units, the actual consumed write capacity units. So now I've got 2 different metrics on this graph right here, and I can see that neither one of these metrics have any data, right? There's data, but it's all zeros, right? I'm not actually consuming any capacity units across this entire 1-week period. So it's pretty safe for me to say, just looking at this metric data here for the GSI, that nobody's using this GSI. So it's probably safe for me to go out to that table. So let's go back to the DynamoDB service here. And then let me find the table, Trevor Products Provisioned. Then I will head over to the Indexes tab right here. And I can see I do have a GSI right here. So I could probably go ahead and just delete that GSI from a table, and I can save cost for the provisioned throughput for the GSI, and I can also save on the storage capacity of whatever the GSI's storage is right here. So if I have a really large table that's maybe got 100 gigs of storage, then I'm going to be paying additional storage costs for the GSI, plus I'm also paying for the additional capacity units that are allocated to that GSI in addition to the configuration of the base table as well. So if I take a look at the base table over under the additional settings right here, the base table has provisioned read capacity units of 1 and provisioned write capacity units of 1. And then down here under index capacity, you can see that it has its own separate capacity as well. So you're paying for all of that. And if you're not using the GSI, but you still need to keep the base table around, then you can just delete the GSI. Again, GSIs can be deleted, but LSIs cannot be deleted from an active table. You have to recreate the table with no LSIs or whatever LSIs you want to exclude excluded when you create the table, because you can only manage those at table creation time. But with GSIs, I can just go in and say, you know what, I'm not using that GSI. I can see that right here from the metrics. So I'm going to go ahead and just delete that GSI from my table. And then that'll save me the storage as well as the capacity for that global secondary index. So let's go back to browsing our DynamoDB metrics over here in the Amazon CloudWatch service. And if we take a look at all of our DynamoDB metrics right here, looks like I may have gotten signed out here or having some kind of network issue. So let me just pause really quick. Okay, so we'll just go back to browsing our metrics once again. I can also go over to table operation metrics right here, and this will give me some metrics about activities that are being performed within the table. For example, I can see if table scan operations are happening, or get item operations are happening, or transactions like transact write items. I think I had some old data where I was doing some transact write items maybe a couple of weeks ago or something in this particular table right here. So you can see that those metrics are active right here. I can also see things like the latency. So that's the actual metric that I'm getting right here, is what is the latency on those requests. Also for scan operations here, I can see what the returned item count is. So I can see if items are actually being returned, or if I'm just wasting capacity doing a scan that's filtering out a bunch of items that aren't actually getting returned. I have a separate video that talks about table scans, so feel free to check that out on the Stratus Grid channel as well. And so this data is really just helping me to kind of understand what's happening in this table. Are operations actually happening or not? And then if I go into the table metrics, you're going to see very similar metrics to what we had with the GSI, where on my Trevor Products Provisioned table down here, I've got consumed read capacity units, consumed write capacity units. And across this 1 week period, I'm probably going to see that I've got zeros for both of those, because I don't think I've really been using the table at all. But of course, I can actually use the table by just going to explore table items over here. And every single time that I run an operation here, it's going to be actually consuming some of these read capacity units. Or if I go over here and say I want to create an item, or if I want to edit an item, let's say I just maybe change the price of this item right here from 452 to 453, that's going to consume write capacity. If I, change it again to maybe 454 instead, that's going to consume write capacity as well. And so then if I were to go down to kind of the hour level metrics right here, within about a minute, maybe 2 minutes or so, whenever this data refreshes, I should see that there's actually now been consumed write capacity and some consumed read capacity for this table, because I just accessed it through the DynamoDB console. So these CloudWatch metrics can help you to understand, is the table being used? Yes or no? If it is being used, what is the difference between the provisioned capacity and the actual consumed capacity? And it looks like I'm still having a network issue here, so hopefully this graph will load eventually here. But as you can see right up here, I still have some metrics active from my index. So let me go ahead and just disable those index level metrics right here, and we'll just take a look at the table metrics. But we should basically be seeing that over a 1 hour period, I have provisioned capacity of 1, because it's just hard coded at 1. Provisioned write capacity is also 1. So read and write provisioned is 1. And then for the consumed write capacity, it's all zeros. For consumed read capacity, it's all zeros as well. And so if my provisioned capacity was like 100 or 1,000 or something like that, and my consumed capacity was like 10 or 15 or somewhere in that range, then I know that that delta is something that I need to optimize on. I need to bring my provisioned capacity down closer to what my actual consumed capacity units are, so that I'm not wasting all of those extra capacity units in my AWS spend, right? All right, so if we maybe just refresh here really quick, maybe we'll see a little bit more interesting data where we're actually consuming some of those capacity units from the base table. But sometimes this data in CloudWatch does take a minute or two to actually populate. So, and it looks like I'm still having some kind of networking issue here actually loading this data. All right, now I think the last thing I wanted to talk about in this particular video is around monitoring table usage, but from a slightly different perspective. So right now we're taking a look at the metrics for the table. So this is telling me stories about the read capacity and write capacity as far as how much is provisioned, how much is actually being consumed. But if I need more data than that, I might need to know what application is accessing the table. And if I need to answer that question, this metric data is not going to tell me that. It doesn't tell me what IP address is a request coming from. It's also not telling me things like what is the host header or the, I should say, the user agent of the application that is accessing the DynamoDB table, right? The metric data just simply doesn't contain that. And you can see this graph finally loaded right here. And you can see I did actually consume a few read capacity units. I also consumed a few write capacity units here as well. So that is showing you that these metrics are actually live. They are per minute metrics, which gives me a lot of granularity to see what's happening inside of my DynamoDB table. All right, so how do we answer these questions about what application is accessing my DynamoDB table? What's the IP address? What's the user agent? So that helps me to kind of narrow down which specific application it is so I can go talk to that development team and figure out if their application needs continued access to that table, if there's any configuration changes I need to make to the table, like read and write capacity units. I can go notify that team and say, hey, just so you know, I'm doing some cost optimization work. I'm going to let that team know that I'm going to potentially be making some changes to the capacity for that table and make sure that they're on board with those changes just in case any issues crop up going forward. So to do this, what we can actually do is check out CloudTrail data. So CloudTrail is essentially audit logs for different services in AWS, including the DynamoDB service. So what we can do in CloudTrail is actually target a very specific resource, like a very specific table that we want to monitor for a certain behavior. And then what we can do is emit those logs over to Amazon S3 for kind of long-term audit log storage, but we can also emit them to the Amazon CloudWatch logs service, which is actually right here in the CloudWatch console. So we can actually create what's called a log group here, and we can emit those logs directly into the log group, which makes it a lot more interactive for us as an engineer. If we're just doing some investigative work, we can actually just go look at that log stream, or log group, I should say, and see in a little bit more real time what's happening. So rather than having to process the CloudTrail data from S3 using some kind of additional tooling, we can just go straight into the console here and kind of explore what is happening with that CloudTrail trail. Looks like I'm still having some networking issues here, so hopefully this clears up in just a second. But once the CloudTrail service does load, I can go down to Trails here, and I don't really want to capture all the audit logs from my account, right? I don't care about EC2, I don't care about VPC or EBS or Lambda or step functions or anything like that. All I care about is what's happening with my specific DynamoDB table. I want to see if there's any activity going on in that table. So what I can do is say, create a CloudTrail trail. And I want to look at that table called Trevor products provisioned, or whatever it's called, right? And so I'm going to go into the trail name here and say trail DynamoDB Trevor products provisioned. And then I'm going to just have it use an existing S3 bucket. I'm going to search for trail here and just say, I want to use this particular bucket right down here. And then I can also, let's just disable encryption for now. I don't really care about that at the moment. We'll also disable log file validation. Don't really need that. But this optional feature right down here called CloudWatch Logs, if I enable this, this can send the data in addition to S3 also to the CloudWatch Logs service. And if you're doing kind of real-time investigatory work, I don't know if that's a word, but investigation work, then you can enable this and then just go directly into the CloudWatch console and actually kind of see those events in near real time. It's not quite real time, but it's kind of near real time. And so what we could do is say, okay, just go ahead and create me a new log group here. And I want you to send those logs to that log group. So I'll create a new one here called StratusGrid demo DynamoDB Trevor products provisioned. I think that'll probably work. Okay, it can be up to 512 characters long, so that should be perfectly fine. And I'll go ahead and just choose an existing role here as well. So you'll want to create a IAM role in the IAM service that you can use from CloudTrail, so that the CloudTrail service has access to emit data to the CloudWatch logs service, as well as S3. So in this particular case, we are going to go to the next screen where we can actually choose which events we want to capture. So now that we've chosen our destination for where the data is going to go, now we need to say, what events do we actually want to capture? And so in this particular case, we want to see read and write operations to a DynamoDB table, right? We want to see a get item, delete item, update item, API calls, transact write item, transact read item, things of that nature. And so these are called data events. So these are not management events where we're creating a new table or changing the configuration of an existing table or deleting a table, right? Those would be considered management events because we're managing the table itself. But in this case, we actually want to see the item level events. This is kind of like object level logging in S3, where I don't care about the bucket configuration changes. I don't care about creating a bucket, deleting a bucket, changing the configuration of an existing bucket, that kind of thing. I want to see what's actually happening to the objects inside of that S3 bucket. And so in the DynamoDB service, a data event is essentially the same thing, where I don't care about the table, I care about the items that are actually being read and written in the table itself. So those are called data events. Now down here, we have the ability to use these advanced selectors. So I can actually say, I want to go to the DynamoDB service here, and I want to log certain types of events, right? And in this particular case, I'm just going to say I want to log all events. And then I can specify what types of events I want to capture. So if I do custom, I can actually filter things down a little bit more here. So I am going to choose custom in this particular case. And so what I'm going to do is say, I want anything where the resource ARN is equal to the ARN, the Amazon resource name of my DynamoDB table. So I'll come back over to the table right here. Let's find Trevor products provisioned. And then we need to find the ARN, which should be right down here. So I'll just copy that to my clipboard. Then we'll come back here and just paste that in. So basically, I want any data event that's coming from that ARN to be included in this CloudTrail trail. So then what I can do is say next, and finally, we can go ahead and create that trail. And so once that trail's been created, that links these audit events coming from that table, again, the data plane events, and it's going to send them to the S3 bucket that we specified and the secondary destination, which is the CloudWatch logs log group that we told it to create. So now we have this new trail that we just created right here. We can go ahead and go into the configuration and change the configuration of that trail if we want to. But what we're going to do is actually go over to the CloudWatch logs service. So let's head back over to the CloudWatch dashboard. And then we're going to go into the logs service. And there's a relatively new feature called live tailing in CloudWatch. Let's actually do a search for CloudWatch new live tail. And yeah, that was actually released very recently, less than a year ago. So this allows us to actually interactively see new log entries as they're being emitted into a log group in CloudWatch. And so this is a really nice way to kind of debug and see what's going on inside of a DynamoDB table by just creating a trail, linking it up to a log group, and then we can see right there in the console what is happening. All right, so now that the CloudWatch logs console is finally loaded here, let's go over to the log groups right here. And we should see in just a moment here that the log group that we created during our CloudTrail creation should exist. And sure enough, right down here, when we created the CloudTrail trail, the CloudTrail service actually went out and created this log group so that it can start putting data into there. And then if you're familiar with CloudWatch logs, you might know that a log group actually has individual log streams in the group, and those kind of roll up to the group level. So down here at the bottom, we can see that there's been a single log stream created, and that I can actually see that there's an event inside of here, right? So I can expand that event, and now I can actually see a little bit of information about where a request came from. And so right down here, I can actually see that there is a user agent. So I can see that a Lambda function appears to have accessed DynamoDB somehow. It looks like it's getting some quota information about DynamoDB. I can see what region it's coming from. I can see the source IP address of that request as well. And so with the source IP address and the user agent, that helps me to kind of narrow down what application is actually accessing this particular DynamoDB table. And if we take a look at the target ARN of the request, so this is going to be the principal right down here. I'm not entirely sure why we are getting this particular event in here. It must have matched somehow. Let me do a quick search for DynamoDB in here. So I'm not entirely sure why this particular item is matching, but if we go over to the table itself, let's go to the DynamoDB service, and we start playing around with data, like just doing a scan or a query or changing a item or adding a new item into the table, then we should see that activity eventually show up in the CloudWatch logs group, and that'll kind of show activity, right? And so we can kind of narrow down where that's coming from. So I'll just run a scan a few times here. No big deal. We could, again, maybe make a change to one of these items here, like changing the price of one of the products in my table here. Let's just make a couple of changes here really quick. And then if we come back over to CloudWatch, I can just click on this button called Start Tailing right here, or I could navigate over to Live Tail here on the left-hand navigation. But what that's going to do is it's basically going to load this log group into the Live Tail feature here. And then it's going to sit here and it's going to wait for log events to match the filter. So basically, I'm saying I want to see everything from this log group that I've created here. So anytime that I run some different operations right here, let's say kitchen fork -5, create item. So now I created an item there. And after a few moments, I should see those audit events pop up right here inside of this live tail. So this is giving me kind of a near real-time view of what's happening at the item level or at the application level, kind of, so to speak, inside of that DynamoDB table. And that helps me to kind of figure out what's going on, what application's accessing the table, what is the application doing? Is it reading data? Is it writing data? Is it doing transactional writes? That kind of thing. I can see very specifically what operations are being performed against this table. Let me just pause really quick while I wait for a couple of these events to pop in. All right, so as you can see, it took a few minutes here. So I've been waiting almost 5 minutes here. And these events did finally populate into the live tail view. So now I can just close the filter here. And then if I want to, I can just drill into any of these events right here. And so if I open up one of these events and scroll down a little bit, you can actually see right here, I've got the source IP address where the request came from. I can see the exact event name that was performed. So in this case, I did a scan operation. I can also see some of the request parameters here. So I can see if there were any attributes that were projected into the view where I can subselect certain attributes from items. I can see if it was a strongly consistent read or an eventually consistent read. You can also optionally return the consumed capacity. There's actually an API parameter where you can specify that you want to return the capacity that was consumed. I think I talk about that in one of my Rust programming videos on DynamoDB as well, so make sure you check those out. But this really starts to answer some questions for me about what's happening inside of this table, or what kind of operations, are there scans happening? If I drill through these events, I should also see a couple of write operations be performed as well. Looks like these are all scans right here. So let's keep going through some more of these events right down here. So there's another scan operation. There's another scan operation. There's another scan operation. We've got a few more right here as well. There's another scan. Let's see. All right, so this one right here is an update item request. And so you can see it right here under the request parameters. I can see the affected table name, which we already kind of know because we limited our CloudTrail to that specific table ARN. But then we actually can see which specific partition and sort key of the item that was actually updated right here. We can also see that the attribute updates here were that we affected the price attribute. We changed the price attribute, we did a put operation against that, and that is the item that was updated. So this is allowing me to kind of see, again, the user agent field, as well as the IP address of the application that's actually hitting my DynamoDB table. And as an engineer, this helps me to go kind of identify which service team is accessing this application. Now, in this particular case, you can see that my user agent is actually a web browser. But oftentimes, you can actually specify a user agent. So let's say that you're developing a Python application using the Bodo 3 module for the AWS SDK. Can I set the user agent? And there is actually a way for you to specify an application name inside of the user agent. So if you create your Bodo configuration, you can actually specify what your user agent string is. And the process for that really kind of depends on which AWS SDK you're using, but Python SDK is obviously very popular. So if you are doing that, you can create your session configuration before you actually create a service client for DynamoDB in this particular case. And that would allow you to change the user agent header so that you could actually identify a specific application. Like maybe it's a finance application, maybe it's a internal operational tool. But by using that user agent creatively in your environment and then using CloudTrail to actually monitor which applications requests are coming from, that can help you identify what's happening in these DynamoDB tables. So not just the CloudWatch metrics data that's telling me if the table's being used and how much capacity of the table's being used, but then CloudTrail helps me identify who is accessing this application and how often are they accessing this table in DynamoDB. And I can also see which specific operations they're performing. Are they doing scan operations? Are they doing query operations? Are they doing transactional operations and things of that nature? So using CloudTrail creatively to really narrow things down to a specific table that I'm interested in can help me answer a lot of questions about how DynamoDB is being used within my organization. And then from there, I can start to make more intelligent cost optimization decisions for DynamoDB that are not going to negatively impact those workloads. So I know there's been a lot of information in this video. We're well over an hour at this point, but I wanted to go through some of these different concepts with you so that you really understand comprehensively how to go about doing cost analysis on your Dynamo tables, but also how to change some of those configurations to really extract the most value out of the DynamoDB service. So thanks again for joining us. Make sure that you subscribe to our channel to get notified about future videos that we publish. Leave a comment down below and let me know if there's any specific things that you learned from this video or other topics that you're interested in around the AWS ecosystem. And we'll see you in the next video. Take care.